Hi, I'm Rajvijay. I welcome you all to Mathscriber. I'm in the process of creating a complete theory course of ALL Combined Mathematics step by step with no step skipped. This is lesson number 3 of Trigonometry tutorial series. In the previous lesson, I discussed about the quadrant rule and basic trigonometry value conversions. In this lesson, I'll be discussing how to find remaining trigonometry values when one trigonometric value has been given. Before I start, I must say, if you are fond of learning advanced math stuff, please like and subscribe to stay tuned. And to get to know about ALL classes I conduct, visit mathscriber.com or dial this number. So here we go, let's get started. In the previous lesson, we discussed about the quadrant rule. Now, when you include angles inside quadrants, now 0 degrees to 90 degrees, which is the first quadrant, 90 degrees to 180 degrees, which is second quadrant, 180 degrees to 270 degrees, third quadrant, and 270 degrees to 360 degrees, which is the fourth quadrant. Now, the angles which are between 0 and 90, which is first quadrant, all the sine, cos, tan values will be positive. And in the second quadrant, only sine values will be positive and tan, cos value will be negative. And in the third quadrant, only tan value will be positive and sine, cos values will be negative. And in the fourth quadrant, only cos values will be positive and the sine and tan values will be negative. So, having this said, now when you consider a right angle triangle, and this angle is theta, and the opposite side is simple A and the adjacent side is simple B and the hypotenuse is simple C. Now most of the time you are given only two sides. So using the Pythagoras theorem, you should be able to find the remaining value. Now let's say A and B given and C is not given. So you can do, now using the Pythagoras, C square will be A square plus B square. So we can find C by the square root of A square plus B square. Now let's imagine A and C given and B is not given, so B square subjected, so then B square can be written C square minus A square, so B can be written square root of C square minus A square. Now when C and B given, when A is not given, so we can write A square equals C square minus B square. So A can be written square root of C square minus B square. Now when you are given a value, now let's say something between 0 and 90, which is the first quadrant, everything will be positive. Now then sine theta is opposite to our hypotenuse, cos theta will be adjacent to our hypotenuse, and tan theta will be opposite to our adjacent, and all these values will be positive because here sine, cos, tan, all the values are positive. Now if you consider the second quadrant, which is between 90 degrees and 180 degrees, so then now let's say I'll just write sine theta equals A over C, cos theta equals B over C, and tan theta equals A over B. By the way, in this second quadrant only sine is positive, so this is positive, but what about these two? These should be negative. This is what you must understand here. Now in the third quadrant, now let's say okay, theta between 180 degrees and 270 degrees. Then we just try these values first of all. Sin theta is A over C, cos theta is B over C, and tan theta is A over B. But in this third quadrant, only tan can be positive. What we do is, first of all, we just basically find this A, B, C values using this Pythagoras when two values given. Now let's say imagine sin theta given, so A and A over C we know, and cos theta and tan theta, in order to find, you should need this, we need this B. So using this formula we can find the value of B, and we just try the values. Later on we see which quadrant these belong. So it is third quadrant, so just only tan can be positive, so we put minus signs in front of this, and this is positive. Now finally, when we consider the fourth quadrant, it is between 270 degrees and 360 degrees. So when you write the values, just first of all, now we have to see first of all, this is the fourth quadrant, which means only cos can be positive. Now here we go, we put positive here, and these values will be negative. So that's all. Now this is the basic concept, very simple. Now having said this, I'll be discussing 4 examples for you to understand when one trigonometry value given, how we are going to find the other 2 values. So let's see those examples now. Alright, let's look into these examples. Now in this first question, in the question itself it's given sin theta is 3 over 5. But now we are supposed to find what is cos theta and what is tan theta. Now first of all, you must know sin theta means opposite over hypotenuse. And so now if you take a triangle, right angle triangle, now if this is theta and sin theta means opposite side over hypotenuse, so this will be 3 and this will be 5, and using the Pythagoras theorem you can find this side. Now let's say this is x, so x square is 5 square minus 3 square, which is 25 minus 9, which is 16. So x will be square root of 16, which is 4. So now here we are writing the answers. Now this is 4. So cos theta means adjacent side over hypotenuse, which is 4 over 5, and tan theta means opposite side over adjacent, which is 3 over 4. Now we have to look into this. Now between 0 and 90 means it is the first quadrant. All STC, all, that means sin, cos, tan, all will be positive. So this is a positive value, this is a positive value. Moving into the second example. Now cos has been given. Why it has been given minus? Because this is in the second quadrant, only sin can be positive. But when we are finding the remaining trigonometry values, which are sin theta and tan theta, temporarily we forget this negative sign and we just deal with the magnitudes of this minus 5 and 13, which are 5 and 13. Now if you take a right angle triangle, now if this is theta, and as you know cos means adjacent side over hypotenuse, so this is 5. Remember, we are not considering this minus, we are just taking the positive value temporarily, and this is 13. So using the Pythagoras theorem, so this side we can write let's say this is x, so we can write x square equals 13 square minus 5 square, which is 169, minus 25, which is 144. So x will be square root of 144, which is 12. Now, so then we can write, so then x will be 12. So sine theta means opposite side over hypotenuse, which is 12 over 13, and tan theta will be opposite side over adjacent, which will be 12 over 5. But this is the second quadrant between 90 and 180 degrees. If you remember, all STC S, only sign will be positive. So this tan can't be positive. So we put a minus sign at the end. Sign is positive because the question itself, it has been given, it is minus. So answer will be sine theta is 12 over 13 and tan theta will be minus 12 over 5. What you have to remember is we are putting this minus sign after finding all the magnitudes. So moving on to the third question. Now tan theta is given. They are mentioning about the third quadrant, 180 and 270. So tan is positive. So if when we are finding the sine theta and cos theta, first of all, we'll find the values. Later on, we'll look into the signs. Now, if you draw the triangle, now this is theta, and tan theta means opposite over adjacent. So this is 5, this is 7, and we are supposed to find this x. So if you remember, x square equals 7 square plus 5 square, which is now in the previous two questions we had nice answers, but now here these guys are not simplifying. So now 7 square is 49, 5 square is 25. So 49 plus 25 will be 74. And so now x means square root of 74, which is not a beautiful answer, but I intentionally kept the answer like this, kept the question like this to get this kind of an answer for you to understand. Always in advanced level we can't expect beautiful answers with perfect square roots. So now then this x will be root 74. Then so sine theta will be opposite side over hypotenuse, which is 5 over root 74, and cos theta will be adjacent over hypotenuse, which is 7 over root 74. But remember, this is third quadrant, only tan can be positive, so sin theta and cos theta will be negative answers. Finally, the final problem, sin theta is given minus 2 over 5, theta between 270 and 360, which means this is the fourth quadrant. Remember, only cos can be positive. So, but as usually, when we are finding the values, first of all, we take the magnitudes. So, we temporarily forget this minus sign and we are drawing this right angle triangle. And this is 90 and this is theta. Now opposite side over hypotenuse, remember we are not taking this minus sign. Opposite side is 2, hypotenuse is 5, and now we are supposed to find this x. Now we are going to find cos theta, or is cos theta, and tan theta. Now using the Pythagoras, x square equals 5 square minus 2 square, which is 25 minus 4, 21, and so x will be square root of 21. So x equals 21. So cos theta will be square root of 21. Okay, now cos theta is adjacent side over hypotenuse, which is root 21 over 5, and tan theta is opposite over adjacent, which is 2 over root 21. But this is the fourth quadrant, only cos can be positive, so tan has to be negative. So this is it. It's so simple. When you are given one trigonometry value, we can find other trigonometric values, and I didn't discuss about sec, cosec, cot, but by the way, when you can find this basic three, just simply you have to take the reciprocals to find sec, cosec, cot. So that's it for this lesson. See you from the next lesson with a new chapter. Goodbye.